this session. So you'll mute yourselves, or I might have to mute y'all if the feedback gets too much. All right, y'all, got 3 weeks left. Okay, and I think I can show you a schedule of that in a couple seconds. Let me get my folder over here. Let me open it up to this. You can see all the stuff I shoved in here. Where is that? Bear with me here. I kind of wanted to show you how I kind of thought we might map out everything, and darn it. Yeah, here it is. Okay, so, all right. So this is where we're at. We're at Monday, Tuesday. So today we're going to continue looking at quartiles and box and whiskers, right? And then the end of the week, we'll get into the third section of chapter 7, which is basically what we're doing. We're just not going through the particular chapter. And then next week on Monday, we'll do something called the standard deviation. Now, there was a question on the homework that asked about the standard deviation. It was a really small sub question, so not a big deal. We're going to get to that next week. And then the seniors' last day is going to be the 14th, 15th. We'll look at z-scores, which is a statistic people use to categorize everybody in a population based upon a scale, 0 to positive, 0 to negative. We'll look at see how to do that when we get to z-scores, and then we'll review, and then we'll finish up with the last quiz. Okay, so I just thought I'd share that with y'all. That I do have a plan. It's just kind of hard to fix it since, you know, the medium in which we're doing this is a little whacked. All right, so here's the warm-up, and so we just have 2 ways of displaying data: the stem and leaf plot on the left and the frequency table on the right. Okay, and when we make our bar graphs, I specifically tell you how to do that for number 1. But if we just went by tens, notice the stem and leaf basically is the bar graph. Instead of going up and down, the numbers are going left and right. So if you just rotated this, then the highest bar would be these 9 numbers. So if you did your bar graph based upon tens, you already basically have the bar graph right here. But we're doing it on 5s, so that means we're going to have to interpret these values, right? Okay, and then here you can just make 10 bars going up. Each bar represents these specific events. How many free throws did a particular basketball player get in that game? All right, most of the time, this basketball player gets 1 and 1 free throw. And then a couple of times he gets 2. And, you know, on a rare occasion, it might get as much as 10. So, you know, if you crash the boards, players tend to foul you. So you get 2 free throws. Okay. All right. Now I went ahead and put these 2 on the board. All right. So we're going to make our bar graphs, and then we're going to do the quartiles and medians. All right. So let me stop this share, and you can see what we have here. All right, so then we just want to count how many numbers are going to occur in each of these intervals, and then that's how we make our bar graphs. So we're starting with 12 and 14. So in between 10 and 15, there's 2 numbers. And then 16. So in between 15 and 20, there's only 1 number. And then 21 and 24. So in between 20 and 25, there's 2 numbers. And then we got 3 numbers above 25. So that's 3. Okay, and then now 30 and 35 looks like we got 4 numbers, right? And then 35, wait, did I, my bad, 3 numbers. Because again, this means less than, so not including 35. 35 is going to go in the next bar. All right, so now we got 4 numbers from 35 to 39, and then 40 goes in the next bar. Okay, and so we got 4 numbers. And then 45 to 49, looks like we got 5 numbers. All right, and then 50 to 54, we got two numbers. And then 55 to 59, two numbers, and then we got two numbers in the 60s. Okay, so you notice if you make your bars, now you can kind of quickly do that. So I'm just going to go ahead and put little marks kind of where they would be. And it doesn't have to be perfect because we just want to kind of get an idea of what this looks like. All right. Now, if you look at that, doesn't that look a lot different than if we just made our bar graphs like this? If we made our bar graphs like this would have been the big bar in the middle. We would have had something like that. And then these two are a little bit bigger. So then you would have had something like that. And then that's only 3. And then when you go on the other side, you would have had something like that. Notice how different they look. And why is this? Because we used a different interval. Instead of going by 10s, went by 5s. This looks more skewed to the left than this does. So when you organize data, it really depends on how you organize it. You can get a different perspective just by changing the scale of the x-axis. All right. And then this one's probably a little more obvious. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And you don't have to be fancy. I'm just going to say that's 16. That would be half. So 11's a little bit more, so I'll just do that. And then 9 is a little bit more than half of 16, so I'll just do that. Okay, and then we can just kind of scale it a little bit. Okay. Notice this is heavy skew. Everything is on the right of the mode. All right, now what we need to do to get the quartiles and median is to count how many numbers there are. And for this, there's 30. And right, if you add the frequency numbers, the numbers on the right, for this, there's 49. Okay, so then you want to do the n plus 1 divided by 2. So for this one, you'll do the 30 plus 1 divided by 2, and the 30 plus 1 divided by 4. And that's going to be 15.5. So in between the 15th and 16th numbers, the median. And this is going to be 7.75. Okay, now remember what we got to do. We got to add 0.25. Okay, so 8. All right, another way to think about that. We got 30 numbers. So if we break them up, we're going to have 15 above, 15 below. Right, so in between the 15th and 16th number. And then we got to break apart the 15 numbers, so the lower half, the upper half. And so this is going to have to be 7 plus 1 plus 7. And so notice the 8th number right after the 7th number. So if you think like that, you can just do it that way. That works. But if you want a formula. Okay, so counting from the bottom, we're going to count up to the 8th number. So I'm going to count left to right. So 1, 2, 3, 4, 5, 6, 7, 8. So 29 is the lower quartile. Okay, now we're going to count from the bottom, which is actually the upper level of numbers. And now we're going to have to count going to the left because we want to count from the top 64, then 62, then 58, then 55, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 48 is the upper quartile. Okay, now the median, we got to count to the 15th and 16th number. Right, well, we know that's the 8th number. So 9, 10, 11, 12, 13, 14, 15. Okay, so 38 is 15. 40 is 16. So in between 40 and 38, the median's 39. All right, let's do a box and whiskers of that down here and see how that relates to this bar graph that we did. Okay, so the minimum value is 12. So I'm going to put a little dot here where 12 might be. The maximum data value is 64, so I'm going to put a little dot over here where 64 might be. 29 is the median, so I'm going to put a little line here just to the left of the 30. 48 was the upper quartile. So the lower quartile was 29, the upper quartile was 48. So I'm going to put a line over here kind of where the 48 might be. And then the median was 39. So I'm going to put a little median number right here. And so that's our box and whiskers. And when you look at this, it doesn't look like there's much difference between the two boxes. And the lower whisker is just a little bit bigger than the upper whisker. All right, and that's because right around here, these are all kind of the same. They're all roughly about the same. That's why that's happening. You didn't get one that jumped real big like you did over here. All right, well now the same thing here. Now this time we're going to have to determine the position, whether we're counting from the bottom or the top. So from the lower end, 1, 2, 3, and then from the bottom end, 10, 9, 8. Same thing, we're going to do the same thing with 49. All right, so 49 plus 1 divided by 2, and 49 plus 1 divided by 4. Okay, and so when we do that, this is 25. So the 25th number is the median. And then here we're going to get 12.5. So in between the 12th and 13th number are the upper and lower quartiles. All right, well, if we count from the top, we're going to be counting from the smaller numbers to the larger numbers, from the 1s to the 10s. So the 16 ones. So the first 16 numbers in ranked order would be 1s. Well, that certainly means the 12th and 13th number would have been a 1. Okay, so this is where the lower quartile is. All right, what about the upper quartile? Well, now we're going to have to count from the upper end of the numbers, from the 10s. And so we got 2 numbers that are 8 or more. We got 5 numbers that are 6 or more. So the 5th number would have been a 6. And then we got 2 plus 5 numbers that are 5 or more. So 7. So the 7th number would have been a 5. So this would have been the 6 and the 7th number. You might notice this is like cumulative frequency. 7 plus 6 is 13. So there were 13 numbers 4 or more. So the 13th number would have been a 4. So in this interval, the 4s, there were 6 of them. That would have been the 8th number all the way to the 13th number if you rank them 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so that means that's where the median is. Oh, sorry, that's where the stupid upper quartile is. So this is the upper quartile. Now again, you have to count from the top to get the upper quartile. You have to count from the bottom, I'm saying bottom, the lower end of numbers, to get the lower quartile. To get the median, it doesn't matter. So where's the 25th number? Well, the first 27 numbers would have been a 1 or a 2. So starting with the 17th number, we would have had 2s. So from the 17th to the 27th number, notice if you add these, so the median is 2. All right, well, let's do the same thing we did here. Let's do a box of whiskers. Now, this was roughly symmetrical, and that's what this box and whiskers kind of indicates. All right. Notice that that helped us because when we looked at making the bar graph using 10s, it looked different. I erased that over here. And then when we made it with 5s, it looked like this. Well, if you use box and whiskers, you don't have to worry about that. you can tell that these two boxes are the same, so this is roughly symmetrical. All right. Well, the lower extreme is 1. So is the lower quartile. Ooh, that's interesting. So I'm going to put a dot right there. The upper extreme is 10. So I'm going to put a dot right there. Well, we got to put a line where the lower quartile is. That's 1. So we got a line through that left dot. The median is 2. The upper quartile is 3. Now notice how that looks. This is how you know you have heavy skew to the right, because the left dot is on the lower quartile, right? And then notice the right box is a lot bigger than the left box. Now, again, this really isn't to scale, but I'm just pointing that out, right? And you notice the right whisker is much bigger than the width of the two boxes, right? Okay, so that's what box and whiskers are helpful. It's a lot quicker to do, you know, and then we don't have to worry about making these visual displays, and then we don't have to worry about which scale do we use, right? Now there's data that's more complicated, and we do want to display data with bar graphs, but if you just want to kind of get an idea of how the data is spread out, the box and whiskers is the quickest way to do that. Okay. All right, let's look at the homework. We're not going to be doing anything new today. We're just going to continue making box and whiskers plots. So the homework, I think, is either 15 or 16 problems where you do that. And you're not going to have a lot of numbers. I think the most amount of numbers is 11, if I remember correctly. All right, so let's go ahead and look at the homework. Now, you only had the odds. All right. So some of these, and I'm just throwing down the answers, but you can look at this display, and so they're asking you, based upon the display, what you would call these. Well, 3 would be the least value, the minimum. The third quartile, so the first one was the lower quartile. The second one is the median. The third one would be the upper quartile, so 11. And I don't know if I said this, but sometimes we call those Q1, Q2, Q3. I can't remember. Sometimes I forget to say that. I mean, it's not a big deal, but okay. Then the median would be 8. The greatest value was 14. The first quartile, the lower quartile, 6. And the range would be the difference between the 14 and the 3. All right, and then here you want to put these in order, and then you can kind of see. All right, now if you look at this, the left box for number 9 is just a little bit bigger. The right whisker is much smaller than the left whisker, right? And 11 is interesting because you got a left box that's a little bit bigger, but a right whisker that's bigger than the left whisker. I mean, this is how weird this can be. And you can see 12. 12 looks like it might be heavy skew, because that dot is right on the lower quartile. And notice that the right box is also bigger and the right whisker is also bigger. So 12 is heavy skew, right? And then 13, they gave you a line plot display. And this is no different than a bar graph, right? The number of dots is the same as the height of the bars. So you can kind of see, it looks like the left box is a little bit smaller, and the left whisker is much smaller than the right whisker. So this is probably right skew for that reason. All right. Okay, now when you look at a box and whisker, remember there's 4 groups. And each of the 4 groups has 25% of the data, but the interval of the 4 groups may not be of the same width. And so that's what happens when you have a wider box. You got a wider width of this interval. Okay, so the range, again, largest minus smallest. Now, when it says describe the distribution, I'm not really satisfied with some of the books choices here because that's really wide open. I mean, you could say that it looks like there's a little bit left skew. You can say the right whisker is bigger than the left whisker, which is basically what they're telling you here. Okay. And then the interquartile range, that means the difference between the upper and lower quartile. So that's basically the interval of the box. So from 14.75 to 10.5, that would be the interquartile range. And that's what that word means, the range between the quartiles. Okay, and then here's where they threw these numbers in. And I was looking at this morning and I realized I might not have said that to you. All right, well, if you look below Q1, that means below the lower quartile is a smaller whisker. Above the upper quartile is a larger whisker. So the spread above Q3 is bigger. Okay, and again, you only had the odds, so you only had to worry about 16 here. But, you know, if you want to know about, I'm 17. If you want to know about 16, I gave it to y'all. So we're just looking at these. And so this might be something that if you work for a sales force, the sales representatives might be compared using these diagrams. It can be competitive. Okay, so it looks like that A is kind of symmetric. Both widths of boxes and whiskers are roughly the same, whereas B has some right skew. The right box is bigger and the right whisker is bigger. All right. Okay. And we're going to talk about skew in a moment, a little more, but let's just go through this. So you can kind of see the answer. And so the single worst sales was B because the smallest value for B. So sales representative A is a little more consistent, narrow range, okay? Whereas sales rep B is a lot more varied. Also had the best day of selling cars. All right, and it looks like the right skew, that means the mean shifted, right? So the mean is shifting to the right. That's what skew means, direction of mean, shifting. All right, and then 19 here, so the 36 would have to be the range because the range is from the minimum to the maximum. And the interquartile range is just between the quartiles, so that has to be less. All right, and here 21, again, the same kind of problem. All right. And so again, how you want to describe the shape, maybe you said it looks like the left box is bigger, the whiskers are roughly the same, although the right whisker is a little bigger. And then here for brand B, the right box is a little bigger, the whiskers are roughly the same, and it looks like the right whisker is a little bigger. So that's what you could say, again, if you want to see what the book said. So they're both, according to the book says, skewed right. I don't know about A. A is not quite as obvious because you got a left box bigger and a right whisker bigger. So this one might be a little more weird. This is what happens when you have a multimodal population. This might be a multimodal population where you got an upper and a lower group. So I wouldn't just say skewed right for that one, but that is certainly true for B because right box and right whisker are both bigger. Okay, see the difference? Darius, I'm answering your question again. Gmail. Sorry, it's May. It's been this way since March. Okay, now I know you guys can read this, so I won't, harp on that. Now, the thing that we want to know about skew, okay? So I'm almost finished with what we're going to do today, okay? We're just going to look at one thing after the homework. Is okay? Anybody have any questions? I mean, whatever it is, please ask. I'm not offended, okay? I mean, because you legitimately want to know, and that's always good. At least you ask. That's all right. I'm happy. I'm happy you asked. All right. when you have skew, the mean is going to pull this way if it's right skew. So if the mean pulls to the right of the median, well, there's 50% of the data to the left of the median, and there's 50% of the data to the right of the median. That's what median is. It's the number in the middle. But if you pull the mean to the right, then there's actually more than 50% of the data below the mean. Right? So if the mean shifts to the right, that means most people in that group are going to be less than the mean. Now, whatever it might be, maybe it's 60% less, maybe it's only 51% less, but it's going to be more than 50% because if the mean shifts this way, it's already on the other side of the median. So below the mean is going to be more than 50%. So right skew, more data is going to be left of the mean. That can be confusing, left, right. That's why it's important to understand why, because it'll help you understand. All right, now what about the other way around? What if the mean shifted this way? And that's what happened on the Thursday warm-up when we had the two classes A and B. All right, the means were less than the medians. So the means were shifting to the left. Well, again, there's more than 50% of the data above the median. So there's more than 50% data below the median. But if the mean shifts to the left, that means there's more than 50% above the mean. So skew left means the mean is shifting to the left, which means you have more values to the right of the mean. And that can be confusing. So let me make that a little more visual with a bar graph. All right, so here's our mode. Now, wherever the median might be, let's say the median is here. Well, if the mean shifts over here, notice that there's more to the right, more than 50%. So left skew, you got more to the left of the mode. The mean is going to shift to the left of the median and the mode. You're going to have more values to the right of the mean. So, okay, is that all right? So the skew is the direction the mean shifts, which means you either have more in the other direction of above or below the mean. So skew left means shifts to the left. You got more values above to the right of the mean. Skew right means shift right. You have more values below to the left of the mean. Okay, that's just a point that's important to know. I don't know if that even comes up on the homework for tonight, but it's important to know that. Okay, everybody okay? Does anybody need anything? I'll probably be updating grades again on Friday, so I'm just rotating every 2 weeks. I'm a little behind. Started to get caught up yesterday. All right. Everybody good? All right, y'all hang tough. Okay, we can do this. Got 3 more weeks. We'll be good. All right, y'all take it easy.